Good morning children, Jai Gurudev. Today we are going to do chapter 11 of science, force and pressure. You have applied force in your day-to-day life at many places. You apply force at many places, such as while playing, while kicking a ball, while lifting an object, while riding your cycle. Even when you're brushing your teeth, you apply little force. Also, when you move the bucket or open or close a door, you apply force. So, in a day, you do lots and lots of activities where force is applied. So, we are going to learn about that force. What is that force? You can see here a table which mentions a few of the day-to-day activities. Now, what you have to do is you have to fill this table and check that while doing the activity, whether you're pushing the object or you're pulling the object, like moving a book which is kept on a table, closing or opening of a door, or when you're taking the water out of the well, what will you be doing? Will you be pulling the object or will you be pushing the object? So complete this table and you will see that mostly we either push the object or we pull the object while we are doing the work or while we are applying the force. So what is force?
In science, a push or a pull on an object is called force. So whether you are pushing a shopping cart or you are pulling a trolley bag, you are applying force on it. Let's see some effects of force. You have seen such a trolley which moves only when someone pushes it. Similarly, a stationary golf ball moves only when it is hit. Also, pushing a toy car makes it move. In daily life, you move so many objects which are at rest. For example, you move your cycle, your book, your toothbrush, your clothes, etc. etc. If you think of an example, you will get thousands of it. So what does a force do? A force makes an object move from rest. You must have seen a footballer kicks a moving ball and its speed changes. This moving wheel starts moving faster, is slightly pushed. Even in cricket, the speed of the ball changes while batting and also while fielding. So here, the force changes the speed of a moving object. It can make it slow or it can make it even fast. Can you think of examples where you use force to change the speed of an object? For example, when you pedal hard, your cycle moves faster, and when you apply brakes, your cycle stops. Here you can see that the ball is continuously changing its direction, and the reason is the force. The force changes the direction of the moving object, and this can be seen in a badminton court. It can also be seen in the cricket ground when the batsman hits the ball. It can be seen in a football ground as well. So, the force changes the direction of motion of an object. I am sure you can also think of many such examples where the force changes the direction of motion of an object. Force can also stop a moving object. And you must have seen this phenomena in playgrounds. You must have also seen when application of brake is there, whether it's your cycle or a car, the object stops. And same thing is used to stop a ball in the playground. Do you have any other examples where you use force to stop a moving object? Think of that. You must have experienced that when you press a ball, its shape changes. Same thing happens with the spring as well, and also with the rubber band. If you take the balloon and press in between your palms, its shape also changes. So this shows that force changes the shape of an object. And there are many events that we do in our day-to-day life where we change the shape of an object using force. You think of as many examples you can, you will find ample of them. So, the next thing that the force does is it changes the shape of an object. So here is the summary of what are the effects of force on a body. Sometimes more than one of these effects can be seen. For example, if a ball is hit very hard, it changes its shape, it changes its speed, and it also changes its direction of motion. And sometimes no effect is seen even if you apply the force. For example, if you push a wall, it will neither change its shape nor will it move. Force can act on an object only when there is an interaction between the objects. It can be two objects or more than two objects. If there is no interaction between two objects, no force can show its effects. Let's see some examples here. It is not possible to push a car without touching it. And similarly, if you don't touch each other, will it be possible for you to push each other? No. So whether you are fighting for a toy or an animal is being pulled against its will, everywhere the two persons or two objects have to be in interaction to apply the force. Let's now try to understand the magnitude of force in brief. You can see that in this picture, two people are pushing a heavy object in the same direction, and by your experience, you know that it will be easy for both of them to move the object now. Now see the second picture. You can see here that the two people, they are moving the object in opposite direction. So what will be the result now in this case? We can understand it from this image. When the force applied on an object is in the same direction, it adds up to one another and the net force or the total force becomes more, and so it becomes easy to push a heavy object. But if the forces acting are in the opposite direction on a particular object, the net force or the total force acting on it is the difference between the two forces. In such a case, the object will move in the direction of the greater force. Now let's learn about two types of forces. The first one is contact force. Whether you're pushing a car or you're pulling your toy, whether you're hitting a ball, playing in a big playground, lifting a heavy object, in all such cases, you need to touch the object and then only you can apply the force. Similarly, even animals, whether they are pulling the cart or carrying you on their back, they are also using a contact force, because without being in touch with each other, the force cannot be applied. So such forces where you need to touch the object to deliver the force is called contact force. There are two types of contact forces: muscular force and frictional force. Here, in all these examples that you saw, your muscular force was applied. You must have seen that a ball rolling on the ground comes to stop after some time. If you stop pedaling your cycle, that also stops after some time. Similarly, when you're writing with your pencil, the lid of the pencil becomes smaller and smaller. And when you slide down through a slide, it's easy because of the smooth surface. So all these are examples of friction. Friction is a force which acts on all moving objects, and it always acts in the opposite direction to the direction of motion. And because this force arises due to contact between two surfaces, it is also an example of contact force. Now coming to non-contact forces. Non-contact forces, as the name says, are such forces where the two objects don't need to be in contact, or the two objects don't need to touch each other to experience the force. Such non-contact forces are magnetic force, electrostatic force, and gravitational force. Here, the object experiences the force from a distance. Let's see some examples of these forces. Here, the object is at a distance from the magnet. The two things are not touching each other, but still you can see the object is experiencing a force of attraction, and because of that, it is moving.
So here you see the example of magnetic force which is experienced from a distance. So it is a non-contact force. The next example of non-contact force is electrostatic force. You must have experienced your hair standing like this on your head on some winter days, especially when you comb them. Also, when you rub a balloon on your dry hair and if you move it away, it will attract the hair. Same balloon, if you bring near thin pieces of paper, it will attract those small pieces because they are light in weight. And here you can see this small kitten. It's having balloons all over its body, and these balloons are sticking to its body due to electrostatic force. Though here the balloons are touching the body, but they get attracted because of electrostatic force, which attracts things even from a little distance. The next non-contact force is gravitational force, which you have learned about earlier as well. Anything and everything which is free to move falls down on the earth because of the gravitational force of earth. This gravitational force attracts things towards itself and does not need to touch an object to pull it towards itself. Not only earth, but all heavenly objects balance each other in the universe with this force. Non-contact forces are also interactive forces because if something is beyond the magnetic field, it will not be attracted towards the magnet. Similarly, anything beyond Earth's gravitational force will not be attracted towards Earth. So even non-contact forces are interactive forces.